All right, in part 2 of bending matrices to our will, we'll talk about how we can change single elements of a matrix. It's just kind of the same way that we would access a matrix, except instead of just accessing it, we're going to change it. So if I want the second element of B, here, let's just put in B, 21 to 26. It's beautiful, isn't it? And if we want the second element in B to be 45, that's literally all we have to do. So we just have to go in there and we have to say, take the second element, make it equal to 45, and it's totally good to go. Then we want to do this with A, so we can do that. This is going to be great. Okay, so A is 1 to 4, followed by 5 to 8, followed by 9 to 12, followed by 13 to 16. So that's fun. Did that come out right? Yes, okay. So I want to change the element that's in the second row. Remember, it always goes row column. So second row, first column to negative 30. That's really all you got to do is just got to go, I want to take this one to that and set it equal to negative 30. Let's see. Change the element that's in the third column, fourth row. Oh, I wasn't paying attention. It always goes row column, right? So I was clearly trying to trick myself. So fourth row, third column to 101, and third column, fourth row, yep, 101. So that seems pretty cool. Now something that doesn't seem, again, like it should work, but it does, is I can actually go in and I can say, well, I'm going to change A 5, 5 to 14, or 15, I guess. And when I run this, look what it does. It's like, oh, well, you clearly did that on purpose. Now remember, if I had, and it's just going to redo it, but if I had tried to access A 5 by itself, again, because it's running it fresh from the top, it's going to say, you can't do that because you've only got it to be 4. So it can't tell me what it is. But if I tell it, well, it's 15, then it's going to put the 15 there, and it's going to fill up everything else with zeros. So isn't that weird? It's super weird. You don't necessarily think that it's going to do that or how it would do that, but it can definitely do that. So you remember how you can do like end, right? So if I wanted to know what's the end of end of B would be like what, 26? Yeah, the end of B is 26. So you can kind of do the same thing. Is you can say you could just obviously just change the end to, whatever you want. And that's fine. But what you could also do is you can say, I want you to add a new element called, pi, or whatever, 3. And now, instead of being a 1 by 6, now it's a 1 by 7. You can actually do all kinds of weird, like if you really wanted to, you could be n plus 20 equals, 8. And then it's going to put in a whole bunch of zeros. 0, 0, 0, 0, 0, 0, until it gets all the way out to there, and then it's going to put an 8. So I don't recommend doing n plus 20, but n plus 1 is a pretty common thing to do to keep adding stuff to the end. Now notice, once you do n plus 1, then you do n plus 1 again. Here, let me make this smaller. So if I do n plus 1 is 3, and now if I do n plus 1 again, it's continuing to go to the end. So it's not the end of where it was originally, it's the end of where it is now. So now the end is here, so the next one I'm going to make 8. Okay? So end is another really great way to access, not just access, but to change or add values to matrices in a way that you can't do it when you're accessing it, but you can do it when you're assigning it, which is kind of cool. Okay. Another fun thing to do that seems like it's kind of a waste of time until all of a sudden, as with everything else, when you need it, you're like, thank goodness I can do that. Is that we're going to be throwing matrices together and doing something that's called concatenation, which is basically shoving stuff together. So I'm going to put these, I'll see clear all this from what I had before. So 1 to 3, 4 to 6, and 7 to 9. B is going to be 11, 12, 13, 14. And C will be, I'll just type it, 21, 22, 23, 24, 25, 26. Oh, and then D is something. D is 31 to 33. Let's see if all these are right. Oops. These should have been semicolons. Okay, so that's right. So I can suppress it This is right, so I can suppress it. This is right, so I can suppress it. I'm just suppressing it so I don't have to keep looking at it. 31 through 33. Perfect. Okay. So what we can do, this instruction says, use end to add an extra row of ones to A. So what I could do, so remember the rows are the ones that are going across. So I can say, okay, let's go to A, and I want the fourth row. So instead of saying the fourth row, it says to use end. So I want to add a row, and I want all of the columns to be equal to 1. Look at that. Isn't that kind of fancy? Yeah, you're impressed. I think you might be able to go like that. Well, clearly you can do that. I was trying to think if you could do, no, because it doesn't know what the end is, so I'm kind of stuck there. So you can do it like that, or you can do the 1, 1, 1 independently. But basically what you're saying is go to the end, make a new row, and for everything on that row in all the columns, put down a 1. Okay? So you don't have to do a for loop if you know what I'm talking about. If you don't worry about it. You don't have to do anything weird or fancy or precious. You can just throw stuff in there, pull this out, and be in really, really good shape. Okay? Add an extra column of zeros to the original A. So I'm going to go back to the original A. So the original A. So I'm going to add an extra column of zeros. So now that we're doing a column, think about what this is going to look like. And again, at any point during these videos, you should pause it, try things out, see if they work. You know, who knows, maybe. Okay, so I want to add an extra column. So it's going to be all the rows, and I want to add an extra column. So that's going to be the new column is going to be 0, 0, 0. Now notice that I had to make my zeros go uppy downy. They have to be, so I could have done it like this. I also could have done it by 0, 0. But the important thing is that the shape matches. Do you see what I'm saying? So the shape is really important. You could also potentially have done this by going zeros, a 1 by 3, but if I just do this, oh, it'll just take care of it for me. I thought it was going to yell at me. I thought I was going to have to put a transpose on it, but it's 1 by 3 and it just made it fit. So that's actually kind of nice. It was not doing what I expected it to. I thought we would have to put in a transpose. If I did this, you little rascal. Okay, well, that's wonderful. Look, it's one less thing to have to worry about. I thought it would have to be vertical, but apparently it's just, it knows what I want. Probably, I can think about why it probably does that. But anyway, that's pretty fantastic. Look at that. I'm excited. Yay. Okay. Okay. So let's go back to our originals. Okay, so this is where it gets kind of fun, and this is more of like almost a game, kind of. So if you have only A, B, C, and D, okay, let me pull these down so I remember what they look like. And we want it to look like this. Okay, so we have these matrices that exist. So what I mean is we don't want to be able to say like, you know, blah equals 1, 2, 3, 21, 22, 31. Okay, I don't want you to do that and then type all the numbers out. I want you to think about how they fit. Okay, so in theory, what you can do, and this seems like a completely ridiculous exercise, and it is. It's a ridiculous exercise. We're just doing it for funsies. So we have this first part here matches this first part, right? 1 through 3, 4, 5, 6. These dudes here, choo is A. Okay. And then the next thing is this dude here, 21 through 6, 22 through 6. Apparently, I meant to do that. That was a mistake on my part. 25. The next thing is C. So let's just start. So what I can do is I can say I want the matrix A, and then I want the matrix C, and then it's going to pop up like that. So it's going to put A, and since all the shapes line up perfectly, then the next thing it's going to do is C, which is pretty cool. Now for the last column, it wants me to put D, like that. Now I think this is where it gets angry at me. If I just put D, now it's getting mad because it's like you can't do three rows, or sorry, three rows, three rows, three rows, three rows, three rows, and then one row. So what I've got to do is I got to tell it, okay, I really need you to flip that D around and then shove it in there. And so as long as the shapes match, you can keep adding more and more to these matrices and kind of shove them together. Does that make sense? Sort of. I'm asking you like you can answer. I mean, I guess in theory you can answer and be like, this doesn't make any sense, and that's okay. So I think I've got a couple more of these here just to kind of play with. So if you can kind of get what we're going on here, I say look down here, pause the video and see if you can get the rest of these. And I'll go ahead and I'll pull this back down so you can see these again. So just using the A, B, C, D, not by typing out any of the numbers, can you recreate this matrix and recreate this matrix here? So I'll pause the video. You should, and pause the video. Pretend you're doing this. It's good for you. It puts hair on your chest. I don't know, something my mom used to say about coffee. Okay, so here's what I want. In theory, you should have tried this, and if not, that's okay. Whatever. I can't spell. What I want to do is, let's see, what is this? The top left corner is B. Okay. And the next thing that happens is 3 and the 6, which are second row, first and second row, last column. Okay. So first and second row, last column of A. Let's see if that gives me part of it. Yeah. And then the last thing I want it to do is I want it to show D. So now I can either put a semicolon, which means go to a new line, or I can physically come in here and type a new line and say D. So it might be easier for you to picture kind of like that. And there you go. So that's all kinds of fun. Yay! All right, and then one more. One more. What is this going to be? Oh, flip. Okay, so it looks like this one is C, but transposed. Yeah, C transposed. And then underneath it is that, and then here on the edge, so let me see if I can figure this out. So I'm assuming I can't do D. Let's see if I just do this. This gets the start, right? Okay, and then I need to add on another row or another column. And I don't think I can just do this. I think it's going to yell at me. Yeah, it's just going to add it as another row. What if I can do D transpose? No, doesn't like that. Okay, so let's leave this here for a second. And we just might have to end up adding an additional thingy on the end. Thank you. Why do you close things for me when I don't want them open? So the first matrix is this weirdy matrix, right, that we just made up. And then the last line is going to be D transposed. If you didn't get this, that's okay. I was just trying to give you the most obnoxious thing I could think of. So there you go. So I actually put a made-up matrix inside a made-up matrix with transposes and weirdness. I guess the point is, if this example makes sense to you, you are 100% solid. And if it'll make sense to you eventually by staring at it, then that's even better. So if this is confusing, you can also do this, where you could say like here, okay? And then you could be like, so then the one that I want is going to be that with D at the end. So you could break it up into two pieces. This. So you can also break it up into two steps if you think that makes a little bit more sense for you. So this is kind of what it looks like in one step, and what it looks like in, there we go. So one step gives you this, two steps gives you this. or that, this, whatever, one more and that. Nonetheless, we're good to go. So you can break it apart into 2 steps if that makes it easier. And honestly, it's better to have code that makes sense to you and works than code that looks sophisticated, but you have no idea what it does. So I don't know if this would have been my favorite way to do it. I might very well have broken it out into this just to make it a little bit easier for the user to tell what's going on. Let's see, what else can we do? You can also, if you need it, you can use things called diag. So diag literally is just going to take, let me get my original A back, wherever she went. Come here, girl. Who's a good girl? Who's a good A? This is a good A. Okay. All right. So this is just pulling the diagonals of A. Oh, shoot. Again, I'm just trying to put these so you can actually see them. So the diagonals of A are 1, 5, and 9. So if I go diag A, that's going to give me 1, 5, and 9. Flip LR of A, if you take a look at kind of what the difference is. Let me suppress this just so we're not looking at too much at once. If you compare the original A to flip LRA, you can tell that it's flipped left to right. So it flips it like horizontally or vertically. I don't know, however you want to talk about it. It flips it left to right. Mirror images it left to right. And not shockingly, flip UD is flipping the matrix up and down, up to down, I guess, however you want to talk about it. So it flips the matrix up to down, like that. Good? Good. Okay, fantastic. Anything else? Oh yeah, and sometimes you just need a blank matrix for no reason whatsoever. You know, because that's a thing that you might have to have. Now, why would I do that? Is because then later I might be like A at n plus 1 equals something, and then I'll be like, oh, look, the first element is that. So that was, like, if you're building a matrix over time, sometimes you'll start out with a blank matrix, and then you'll n plus 1 and n plus 1 and n plus 1 to put more and more stuff on it. So that's kind of cool. So just to kind of pull some things together from what we did in a previous video, you can make a magic matrix like this. It's a pre-built matrix. It's in MATLAB that you can do. So take a minute and see if you can figure out and remember how to do these things. So again, the idea would be that you would pause this video and think about it. Okay. So if I wanted to find the sum, let me see clear this so we're not running everything all the time. Thank you. Oh yeah, sorry. Sum of A. So remember, whenever we do summations and stuff like that on a matrix or whatever, it's going to be doing things based on the columns. So if I just type sum of A, it's going to automatically give me the sum of all the columns. All right, sum of each row. Sum of A transpose. So remember that what we can do is if we want to do things by row instead of by column, we just do it to the transpose. And if you want, you can transpose it back. And that should give you the, now maybe you're seeing something. So this is kind of one of the tricks or features of a magic matrix, is a magic matrix has all of the columns equal to 65 and all of the rows, or not equal to 65, but equal to the same number. All the columns equal to the same number. Sum of all the rows equals the same number. And we can do the sum of the diagonal, the main diagonal. Okay, so the sum of the diagonal is also 65. So remember, that's the primary diagonal going this way. So if we want the other diagonal, a way a lot of people like to do it is, see if I go flip LR A, and then I do that diagonal, it'll give me the previous other diagonal. So like that. So that's what I think I'm going to do. I'm going to put it all in one line too to freak people out, because that'll be fun. I'm going to take the sum of the diagonal of the flip LR of A. And again, that's going to be 65. Now, I'm not saying that you should ever do things like this. You can totally break it out into multiple steps. So you could be like, first part is to flip left right of A. And then the second part is to get the diagonal of the first part. And then the third part is to get the sum of the second part. What happened here? There we go. So something like that. And you're still getting the same answer. I'm just breaking it out. So this here is going to give me 65 just directly. Or I can flip it, take the diagonal, and then take the sum. So I'm taking 3 steps to do it, but that's okay because maybe I'm more confident in my answer this way and I'm getting the exact same thing. So we can definitely manipulate and play around with matrices just to kind of get them to do what we want, because that's what MATLAB was really designed for. Remember, is MATLAB was designed for matrices, and so the whole idea is that we would be able to go in there and manipulate them very quickly and very efficiently and effectively. So it's pretty cool. More yay.